So we wanted to look at some event-driven programming without any network stuff. So probably without a select loop. So let's just have a simpler loop than that. But first, let's define a task that we're trying to do here. So the gist is that we have threading. So we have some events that are being generated, and we're going to use threads here to do that. So I'm going to say gen events is going to be, that's what we're going to need, import time, import random. So it's time.sleep, random. So this program's going to take time to run, right? And then let's event loop dot send event. I'm just going to say like, hey, there's some data for you, and the data is this random number here. And why don't we do for I in range 10? How about it's, can we do this? I plus that. That way we'll be able to tell when it came from. And now let's event okay. So we're using Python 3. Events equals q dot q. Yeah, see, all other things will just come into this queue, I guess. And I'm going to forget how to use queues, so I'll have to pull up some bpython. Or Python 3. Okay, I'm going to need some methods on there. Cool. Events, and then def run forever. We're going to make it a certain size. Q.Q. Yeah, max size. Okay. Okay. Maybe it's, okay, we will need send event. What that's going to do is take the event and stick it in the queue. Okay, so events stop, it's just put. I'm just forgetting how these work. Q.put. Get. And then it's blocking. Okay, cool. Right, so in our def run forever, we are gonna, well, true, we're gonna do e equals self.event events.get, And that's our magical, like, sitting there blocking thing, right? Sort of efficiently, not instead of polling, right? We're not doing get no wait. What is it? Q.get no wait, which we have to do over and over. That would be polling. We're using this special queue thing, which lets us just call get. And put a timeout on it. Q.get. I kind of want to put a timeout on it. Well, we'll do that later. Get the event, and let's self.process event. Well, how are we going to do that? Well, def process event self the event. We also have a bunch of handlers, or we'll call them event listeners. Self.event listeners. Predicate action. This is going to be an inefficient version where we have to check each event is going to be, everyone gets to check to see if they want to do something with it. Event listeners dot append predicate action. So there's not much talking here because I'm thinking a lot as I do this. Threadings should be threading. And oops, event loop. All right, so we're going to make one. And then this is like our library code up here. Oh, we're gonna do that. Then we're going to make some threads. T equals, I'll just write a new one called launch data thread. And what that does is it equals threading.thread, where the target equals gen events t dot start. That's how that works, right? Oh, threads aren't going to work here. Import threading dot thread target equals lambda x, lambda print. Oh, I didn't use, I know. Shoot, oh no, that's fine. Oh, IPython 3 is, shoot. I'm confused. That's still Python 3 import threading thread target is lambda so my question was, what does that block? It runs the other one first for a little bit anyway. Just look at t help of t. How does run work? Okay, run's the one that blocks. Start. Okay, that makes sense. Start kind of spawns it. Start. So if we were to what's supposed to happen here? Just for debugging, print got an event should happen 10 times, somewhat randomly over time, right? If I launch a data thread, Python 3, this is more of a star args kind of thing. Oh, right, same thing. Okay, so we're receiving those events. And the way we're going to do all of our programming, process event, all right, I think that was wrong. Okay, yeah, we're running it blocking. We want to spawn the thread. I don't know how to use threads apparently. I mean, it's true, but what is it? Import threading. T.start. Start thread's activity must be called at most once per thread object. Arrange the run. I may have called more than once. So surely this is gonna. Oh, because I called the function there, that's why. So now we're good of it. Cool. So what process event does is def process event is that we're going to run that event through everybody that's registered to listen for events. So self and E, I'm going to say for it'll just loop through them. For pred action in self.event listeners, if predicate of the event, which is going to be something like, is it a data event or something, then action of the event. There's lots of ways we could do this, but this is sort of a general one. And we're also, so now when we're actually writing our code down here, right, our application code, in fact, maybe we should, well, that's fine, leave it in one file for now. Launch data thread, t equals threading.thread, t.start. So first maybe we'll set up some event listeners, right? So we're going to say event loop.add event listener. I'm going to say, I don't know, if your first element, if it's a data event, then I would like you to print got data x, x1. Cool, if it's a data event, then that should work, right? If Hmm. Okay, so when we run this, because I've added an event listener for that data event that does something, just prints it. I should see that each time this happens. Oops. Great. Cool. Got event. Okay, so this is the gist. Now let's do something interesting with this. The person that asked about this said that they were gathering data, and then once there was enough of it, they were going to do something with it. So maybe I'll have an accumulator thing, I guess. A little overkill to have a class for it. I'm going to say acc equals 0, and we want to add up all the numbers we get. Def add to acc, global acc plus equals x. So we're just printing that we got it. More interesting would be when we get it, instead of printing that we got it, we are going to, if it looks like data, we are gonna add it to acc. And since it gets the whole event, we'll have to grab the second thing, which should be, whoops, we'll have to grab the second thing, which should be a number. Let's add another listener for counting events, maybe. Well, okay, we'll do this, and then maybe print it each time so we can see progress. Print acc. Okay, cool. Now, getting this to shut. Now we can also, right, we can do this with more. That was the whole point, was we can do this with more threads. We can launch some more. Yeah. Yay. Do it with more. Nothing we couldn't do with threads, but doing it with this event loop. I don't know. Let's keep track of when we might be done. Gonna add another thing called def shut down. No, just a thing called shutdown. Well, shut down if shut down on fourth done event. Okay. So done events starts at 0. Each time I'm going to add an event listener for it. If If it's a done event, then let's call shut down on fourth done. There we go. Don't seem like we're, oh, just because shutdown doesn't do anything. If done events equals 4, then event loop dot shut down. They're verbs here. Right. So to pound this in now, let's event loop.py. Let's stick all this in that event loop thing. We're going to need here import time, import random. And then in here we say import event. How about just from event loop import event loop? It's a singleton kind of thing, so we'll just instantiate it in here. We're already doing that. Oops. Indeed. Okay. So what's up? Cool. So programming with an event loop. The gist is that we just write this kind of code, and you'll notice it's all callbacks, right? Everything, we did, I guess we did say launch this, didn't we? We launched those threads. So let's add another thing, which is like run, how about a run every or something, yeah? So we could say, well, normally in event-driven programming, you're just responding to events, right? And we did actually do something here. I mean, you do add event listeners like this, right? But we are doing something. We're launching those data threads. That's fine. I mean, yeah, that's somehow, right, you have to hook it up such that events will happen, and that's what we're doing here. But we could do other things with this. We could, other nice things an event loop could do, like event loop. We could say like run in 10 seconds. That's a thing it could do, right? Because it could keep track of what time it is now. run later. First you'll say when, 5 seconds, and then what we want it to do, lambda print 5 seconds are up. All right, this is another good event loop kind of thing. Oops. This is going to be kind of inaccurate because it'll be the first event that comes in after that time, right? Because each time I'm going to say if, for timed event in self.timed events. We could do it run later, or we could do spawn an event later, but I'm just going to do timed callbacks. Self.timed callbacks. Great, and then we could say something like, what was it? Run later, self when, and then callback. We don't need a start time. We'll just check the time a bunch. So the when is going to be time.time plus when. Time.time is in seconds, right? Yeah, it is. So just add number of seconds, and the second thing will be the callback, and then for each of these timed events, if time t callback, if t is before now, if it's overdue, then go ahead and run callback. See if that works. Oops. I obviously just changed my Vim keys. Big. Whoop, yet? No? What? Not yet? 5 seconds are up. Okay, well that didn't work real well. So first off, it happened too late and happened more than once. The more than once we can fix for each of these. To run equals self dot equals TCB for self.timed callbacks if t is less than now. So that's the removing. But as for why did it take so long to happen, I'm not sure. There we go, 5 seconds are up. Great, right at the right time. So maybe it's because the random, when you do things at random times, it adds up to about 5 seconds. That's why. So, great. So anything else an event loop would do? So when I think of an event loop, I could think of, the browser. If you write JavaScript code, what else can it do? It could run something every once in a while. It can run something when user events happen. It can run something when network events happen. You can just make up events and schedule them. That's what we're kind of doing here. Um, but yeah, that's what I've got. All right. Let me know if you have any more questions.